Okay, so word problems, finally. Okay, so the area of a rectangle is 65 square meters, and the length of the rectangle is 3 meters less than twice the width. What are the dimensions? So what are the length and the width? Those guys. Okay, so we're talking about a rectangle, length, and we know that the area is length times width of a rectangle. At least if you didn't, well, now you do. So this will be the formula that we want to use to relate everything because, well, that formula relates length, width, and area, which is what they're talking about. So I'm going to write it again right over here. Okay, so we know the area is 65 square meters. So I'll replace A for area with that. Now, what about the L and the W? Well, basically, that right there is translating that English right there. So how about we translate that right there and say, all right, the length is 3 less than, 3 taken away from, double the width. That takes practice doing that translation. So that means that any place in this problem I see an L, I can replace it with a 2W minus 3. So I'm going to do that. Now I've got an equation where I can solve for W. I can find that width. So first I'm going to have, or next, I got to get rid of those parentheses. So I get that. Then I'm going to subtract 65 from both sides because I got to get everything on one side so that when I factor, I'm able to set each factor equal to 0. All right. Now it's time to factor, and in the interest of, well, I'm just going to write it down because we've done this a lot. Okay, so when I factor this, going through that AC method, I'm going to get 2W minus 13 and W plus 5. So then I need to set the factors equal to 0. So 2W minus 13 equals 0. And let's see, so I'm going to add 13 to both sides and then divide by 2, and I get 6.5. Okay, and then I set the W plus 5 equal to 0 as well. Subtract 5, and I get negative 5. Okay, now here's the deal. Unlike problems we've been looking at, this one has real-world context. Okay. So what I mean by that is W stands for the width of the rectangle. Can you have a width of negative 5 meters? Doesn't really make sense. So I'm going to ignore that. I throw that away. It doesn't make sense. So the width is going to have to just be 6.5 meters. Well, if the width is 6.5 meters, then the length coming from here, the length has to be 2 times the width, which we now know is 6.5, minus 3, which is 8 meters. And hang on a second, is that right? No, that's not right. It's 10 meters. Okay, there we go. I was going to say, that doesn't, those two don't multiply back to 65 square meters. They multiply to 52. So that's, it's like that. So I'm checking my answer, making sure it seems reasonable. But that's how it's done. And for this topic, that's how they're all done, just like this. And you're going to find that, you're going to get 2 solutions for the first variable, and one of them is not going to work. Okay. That's how it goes. All right, the Pythagorean theorem is something that you can use on a right triangle, a triangle with a 90-degree angle. That's what that symbol means. So the formula is a squared plus b squared equals c squared, where the 2 sides that form the right angle, that form the 90-degree angle, they're called A and B, and it doesn't matter what order you put them in. Now, the last side that does not help form the right angle, that's always called C. That's the hypotenuse. That's always the longest side. So if your C is not your longest side, something's wrong. And this only works in a right triangle. If it's a triangle that does not have a 90-degree angle, the deal's off. All right, so we're going to go 24 squared plus 10 squared is C squared. Or, well, I guess they're using X. It doesn't really matter, but I'll use their variable. Okay, so now 576 plus 100 is x squared. So 676 equals x squared. And then we will square root both sides. We're just doing what we always do. Do the opposite of what's being done to the variable. The opposite of squaring is square root. So those cancel with each other. And we're left with x equals 26. And it doesn't say if it's meters or feet or whatever. So we're not going to worry about that. Now, normally when you square root both sides of the equation, you get the positive and the negative answer. But for this one, we're looking for the length of a triangle, and so the negative doesn't make sense. So we're just going to need that positive 26, and that's it. And that's how it always is for Pythagorean theorem. All right, I see another right triangle. Thinking Pythagorean theorem. This time, we're looking for one of the legs of the right triangle. A and B are called the legs. Okay. So, well, that's cool. So we'll do x squared plus 15 squared is 25 squared. So x squared plus 225 equals 625. Subtract 225 from both sides, and I get 400. And then I take the square root of both sides, and I get 20. And I'm not going to do the plus or minus because, again, it's side length, and negative side length doesn't make sense. This doesn't say what the units are, like feet or meters, so I'm not going to worry about it. And it says to the nearest hundredth, so 2 decimal places. Well, that'll just be 0.00. Okay, which is kind of silly, but hey, I'm following instructions. Okay, now, it's a word problem, but on the word problems here on Alex, they always give you the picture to go with it, which makes it a lot easier. So it's like, okay, well, I can see what's going on right here, but you know, a 13-foot ladder right there, being leaned against the house. The base of the ladder is 10 feet away. How high up the house is it going? Okay, so we'll get, so one of the legs, so these are the 2 legs, our A and our B. So they go on one side of the equation. And then the hypotenuse, 13, goes on the other. So we're gonna get this, and if I subtract 100 from both sides, I get 69, and then I need to do the square root of both sides, and it says, let's go to the nearest tenth. That's 1 decimal place, so that would be 8.3, and this time they do give us units, so I need to include them. It's feet. Okay, so 8.3 feet is going to be the answer. That's how high up the wall this ladder is going to reach under these conditions. Okay, this one's a little different. The longer leg of a right triangle, oh, we know we're doing Pythagorean theorem, is 1 centimeter longer than the shorter leg. Now the hypotenuse is 9 centimeters longer than the shorter leg. How long are all the sides? Okay, so here's my strategy for these, and I think it works pretty good. If you pay close attention, you'll notice that 2 of the sides are both being compared to the same side. The longer leg is being compared to the shorter leg, and the hypotenuse is being compared to the shorter leg. They're both being compared to the shorter leg. So I'm going to say x equals, oh, hang on, I'm not going to have enough room. I'm going to type this. X equals the shorter leg. Okay. So whichever one they're both being compared to, just call that x. You don't have to, but it does make it easier. At least I think so. Okay, now what about right here in that first sentence? The longer leg, okay, is going to be 1 centimeter longer than the shorter leg. So the shorter leg increased by 1 centimeter. And that's our longer leg. Then it says that the hypotenuse, where's that? There's the home button. The hypotenuse is going to be what? Well, it's 9 centimeters longer than the shorter leg. Oh, so shorter leg increased by 9. Okay. So that is how, that's what you got to do first. You got to translate, or you got to define your variables. Now that they're defined, I can say, all right, well, so I've got some right triangle where the shorter leg is x and the longer leg is x plus 1, and the hypotenuse is x plus 9. So now I'm ready to do my a squared plus b squared equals c squared thing. So I square one leg, and add to that the other one squared, and that's the hypotenuse squared. All right, now I got to get rid of those parentheses. So that'll be x squared plus 2x plus 1. Okay, and then the x squared I already had. Then over here, this is, remember, it's x plus 9 times x plus 9, so it's not just x squared, 9 squared. The x squared plus 18x plus 81. Okay, so we got to get everything together on one side so we can factor it and set the factors equal to 0. Okay, so I'm going to subtract an x squared from both sides. Boom, done. I'm going to subtract an 18x from both sides. Boom, I've subtracted 18x. Now I'll subtract the 81 from both sides. And I can factor it the slow way or the fast way. Let's see, what's that going to give me? I think I need a 20 and a 4. That'll give me 80 minus and plus. Okay. So now it's factored. And so when I set each factor equal to 0, I'm running out of room. So I'm going to change colors and say, all right, when I set that to 0, that's going to give me 20. And when I set this to 0, it's going to give me -4. So now, what does x stand for? X is the short leg. Well, you can't have a negative, -4 centimeters for your short leg. So it's got to be 20, which means x is 20 everywhere in the problem. Every x is equal to 20. So we're going to get 20 centimeters for the short leg, 21 for the long leg, and 29 for the hypotenuse. And everything on this topic is done the same way, just like this.